In this video, we're going to be taking some notes on solving absolute value inequalities graphically. So this is a flash of what we've done from the past. We have graphed two variable inequalities and we've solved absolute value equations graphically, and we're going to put those two things together in order to solve an absolute value inequality. So here's example number 1. Solve the absolute value of x is greater than or equal to 3. This is an absolute value inequality because it's got the greater than or equal to symbol in it. So when we solve that, what we're going to do is we're going to graph our solution on a number line. That's a two-dimensional number line like this. And also state your solution as an inequality. So we're going to write it with symbols but no absolute value signs. So let's go through the steps that we would do. For step number 1, we're going to treat each side of the inequality like a two-variable inequality by replacing each side of the inequality with a y. So if I go to my original inequality here and I replace the left side of the inequality with a y, I would have y is greater than or equal to 3. If I then go back to my inequality and I replace the right side of the inequality with a y, I would have the absolute value of x is greater than or equal to y. Now, we like the y to come first when we're graphing, so to put the second inequality into our calculator or to graph by hand, we put the y on the left, which means we switch the inequality symbol. So this, which used to be a greater than or equal to, has become a less than or equal to symbol down here. If you remember the way that alligator eats the bigger function, the alligator is eating the absolute value up here, and it is down here as well. So let's go ahead and graph these. I'm going to graph by hand on this graph up here. My first one, the green one there, is y is greater than or equal to 3. That would be a horizontal line at y equals 3. Next, I have y is less than or equal to the absolute value of x, which is going to be a v that's anchored at the origin. I need to be nice and particular when I'm graphing and really plot these points so that I can tell exactly where my lines cross. I need to do y is less than or equal to. So for this v, I'm going to shade underneath it, and I'm shading all down here. So for both inequalities to be true, I'm on step number 2 here. For both inequalities to be true, we want the overlap of the regions, which is just this zone over here and over here. And then it makes a note, if I'm graphing these on my calculator, if I'm graphing on my Casio, that's all that's going to be shaded, and my picture is going to look like this down here. And if I'm graphing on a TI, it's going to look more like the image up at the top, where it's going to show the most heavily shaded is the overlap. So I'm going to go ahead and put this in my calculator as well, just to show you that. So I'm in my graph menu on my calculator, and in my Y1, I need to change the type. So I hit F3 for the type, hit F6 for more options, and that's where my greater than or equal to symbol is. And I needed y was greater than or equal to 3. Then on my second inequality, I needed to change my type. This one is a less than or equal to. These always have to be different directions because they came from the same problem. And I have option num ABS for absolute value of x. If I go Shift View Window and change it to standard if it isn't already, you can see on my calculator it shades just the overlapping sections. All right, now step 3 is to just identify the x values that satisfy the inequality. Now remember, my original problem right here was the absolute value of x is greater than or equal to 3. And the original problem didn't have any y's in it, and that's why I don't care about the y's for my answer. All I care about are the x values. So where do these things cross? They cross at -3, and they cross at +3. Remember, on your calculator, if you go to GSolve and then intersection, you can see x equals -3, and if you hit the over arrow, it'll go to the second one as well if you can't see exactly where those cross on your graph. So, looking from left to right, what do I want as part of my solution? I want this over here on the left, which was from 3 to the left, because in those places, the absolute value graph is above the line, and that's what I have right here in my original problem. The absolute value graph was the v, and the 3 was the constant, and that's when the v was above the constant, or the shaded part. Also over here on the right, any x values from 3 to the right were also included because, again, the absolute value was above 3. So now I need to do step 4, which is to write down my solution and graph it on a number line. Graphing it on a number line, I'm just going to scroll a little bit here, was pretty much already done. You notice on my number line, I had a solid circle because there was an equal to part, and that's what I had up here in my picture where they crossed. I went to the left, so on my number line, I would shade to the left. I had a solid circle at positive 3, and then I shaded to the right because I was also shaded to the right in my original graph. Writing this as an inequality, I had x is less than or equal to negative 3. If my original problem had the equal to in it, then I needed to keep an equal to as well. And I had over here on the right, x is greater than or equal to 3. In between those two, I need to write an or. Whenever I have two separate sections, so if you have more than one shaded section, you need to list them with or in between the sections. I write or because it's not possible to be both of those things at the same time. I could be one or the other. All right, so go ahead and pause the video while you try number 1. Be sure you solve it graphically. You state your answer as an inequality like this, and you give your answer on a number line like this. Pause the video while you try that one. All right, here's the solution to number 1. I graphed left side as y is greater than or equal to 1 when I replace the left side. I replaced the right side, and then when I switched my inequalities, I got y was less than or equal to the absolute value of x plus 2. You can see the overlapping is the darkest shaded parts. My graphs crossed at negative 3 and at negative 1. So I wanted to the left of negative 3 and to the right of negative 1. I put solid dots because I could equal those numbers also. And then when I wrote my inequality, I have x is less than or equal to negative 3, or x is greater than or equal to negative 1. All right, so let's turn the page here and do example number 2. On this one, we're solving the inequality. Absolute value of x minus 1 is less than 4. And again, we're going to solve it graphically and graph the solution on a number line and state that algebraically. So step 1 is just like before. I'm going to graph the y is less than 4. Notice for the right side, I kept that symbol the same. So y is less than 4 would be a horizontal line at y equals 4. Notice this one's dashed because I'm not equal to it. And this was less than, so I need to shade down from here. My next line, I replace the 4 with a y, and I have the absolute value is less than y, which if I want to rewrite with the absolute value on the right side and the y on the left side, I have to reverse the inequality. So this is a V shape that's been moved 1 to the right. It has a slope of 1. So I'm going to plot that line. Again, nice and carefully when I'm plotting. I'm going to use dashed lines. And this is a greater than. So I'm going to shade up from there, which would be the inside of my V here as I'm shading. So the overlap for this section is right here in between, just this little triangle. If I want to put this guy in my calculator, I need to go back and I need to delete the functions that are already there. I can't just type over them or I won't be able to change the inequality. So for this one, I'm trying to do y is less than. So I'm going to go to the type. I'm going to change it to less than, and that's going to be less than 4. And then for my second one, I'm going to go to the type, and I'm going to change this one to greater than, and that's the absolute value of x minus 1. I'm going to draw, and I can confirm that I have just the inside section. You can see it tries to make a nice dashed line for me there. If I want to see exactly where they cross, I go to GSolve, the isect, and I can see they cross at negative 3 and at positive 5. And that's what I've shown down here on the graph. They cross at negative 3 and they cross at positive 5. So now I just need to interpret my answer. Again, I'm looking for the x values. So I want the x values between the negative 3 and the 5. if I were to write this as an inequality, I would say that -3 is less than x, which is less than 5. And I do that just like I do increasing or decreasing, where I sandwich it in between the two numbers, because I start shading at -3 and I stop shading at 5, going from left to right. So if I want to write this on a number line, when I'm drawing it, I need to show a nice open circle at both -3 and 5. I'm showing the open circle because it's just a less than or a greater than in the original problem. And I show that on my number line, I've shaded in between these two values. Go ahead and pause the video while you try number 2. So there's my solution to you try number 2. My graphs crossed at -3 and at 1, and I was the most heavily shaded right here in between those values. This was the only heavily shaded part. So on my number line, I show that as being between the -3 and the 1 with open circles because I can't equal them, because in the original problem there was no equal to. And down here at the bottom, I write my solution as an inequality. I am the values between the -3 and the 1, so that's an and inequality. I can sandwich it together, and I don't write any equal to symbols. Okay, let's flip over here to example number 3. Again, I've got another inequality to solve graphically, but this one a little something different is going to happen. So I've got my y is greater than or equal to when I flip my, I'm sorry, less than or equal to when I flip my inequality. And I've got my right side of my inequality, which stayed the same. That was y was greater than or equal to -5. So I need to graph those two things. Y is greater than or equal to -5 was a solid line. And when I shade that, it's greater than. So I'm going to shade up. Hold on. Sorry about that. I had a pen in my hand. So I'm shading up. And then my second inequality was a V shape that was moved 4 to the left and up 1. And for this one, it was a less than or equal to inequality. So when I graph less than or equal to, that means I need to shade down. So that's going to be all these parts down here. And what's happening with my overlap? My overlap is technically all of this stuff in here. So where does my overlapping region go? Well, if I wanted to describe all of those x values, this is happening everywhere. Okay, this original problem is asking when is the v above, because it's greater than or equal to, the horizontal line. Well, the v was above the horizontal line everywhere, and it should make sense. When is the absolute value graph greater than or equal to -5? Well, absolute value is always positive, so it's always going to be greater than or equal to -5. So if I needed to write my solution, the way I'm going to write that is I'm going to say all real numbers. On a number line, if I'm graphing all real numbers on a number line, it's the whole entire graph filled in. Okay, go ahead and pause the video while you try number 3. And when you're doing that, just be careful of the fraction and plot your points nicely. So in this one, I was graphing y is less than 2. So that was the bottom half of the graph. Then I was graphing y is greater than this absolute value function. So where's my overlap? There isn't any overlap in this one. So the answer to this would be no solution, which again, we can write the words, we can put little empty brackets, and on a number line, the whole thing is just going to be blank. So how do you know when your solution is no real solution? And that's because none of the graph overlaps. Okay, and if you took this original problem up here and you moved this 3 to the other side, you could also see you would have had 2/3. The absolute value of x plus 2 is less than -1. if I subtracted 3 from both sides to move that over. And then what we'd have here is when is the absolute value less than a negative number? The absolute value is never less than a negative number, so none of my graphs should overlap. Versus how do you know when your solution is all real numbers? And that's when the graph overlaps everywhere from left to right. And if you remember what happened with that inequality, if we had when is the absolute value of something, when is that greater than a negative, we're always going to be greater than a negative because an absolute value is always positive. Okay, one last page here, example 4. We're supposed to solve this one graphically. Again, we're going to do the original problem where we replace the left-hand side with a y. So in this one, it's a little different because I have an x on both sides of my inequality, but I'm still going to follow the same steps as I did before. This one has a y-intercept of 2 and a slope of -1. This is going to be a dashed line when I go to complete it because it's just a less than or greater than symbol, no equal to. This is a less than, so I need to shade below this function. So I'll shade down here. Okay. Now my second function, when I replace, my y would be on the right-hand side, and my symbol was originally less than, so I had to flip it, and this is what I'd put into my calculator or graph by hand. It's a V shape that's been moved 1 unit to the left and down 3. And again, it's going to be a dashed line. This one is a greater than, so when I graph my greater than, I need to choose everything up from here. And then what I want is the overlap of these two regions. The overlap of these two regions is just this strip in between them, and you can see that's highlighted down here for you on your paper. Okay, so we only cross one time. We crossed right here at x equals 2. So now we're trying to identify all the x values that satisfy this inequality. So where is my shading? My shading is anywhere to the left of 2. So when I write that, that's x is less than 2. On a number line, I'm going to have an open circle at 2 because there was no equal to in the problem, and I'm going to shade to the left. If the graphs only cross once, you're only going to have one inequality in your answer. So go ahead and pause the video. While you do, you try number 4 down here at the bottom of the page. On this one, you've got some big numbers, so if you're using your calculator, you might need to zoom out. Also, if you look at my grid that I gave you over here, it's just a set of axes. It's not pretty with a nice grid mark, so we're definitely going to want to do this one on our calculator. So I've graphed this on my calculator in case you got stuck. I can see I've got a little shaded part up on the left, but I can't tell what's going on. I need to zoom out. So remember on my calculator, I hit F2 for zoom, and then I hit F4 to zoom out. Now it's asking me for a center of zoom. I can hit execute right now if I want to keep that in the origin in the middle of my graph, or I could move my cursor and then hit enter, but you have to hit enter. So I can't tell now that I've zoomed out exactly where they cross. If I go to gsolve isect, I can see they do cross at 0. So I had my V shape that had been scooched to the left and up 12. I had my line of x plus 15. Sorry about that. He was scooched 3 to the right and up 12. And then that was going to be shaded down from there. So there's my shading. And then I had y was greater than x plus 15. So that was a nice diagonal line there with a y-intercept of 15. And that one was supposed to be shaded up from there. And then my overlapping region would just be in here. So from where I crossed, which was at 0, to the left. So on my number line, I need 0 on there. There was no equal to in the original problem, so I'm going to graph an open circle, and I'm going to shade left on my number line, and I'm going to say x is less than 0 because it's to the left of 0. So come into class if you have any questions, and you can do some more practice with these absolute value inequalities. You can solve them by hand, or you could solve them with your calculator to help you.